Welcome to lesson 1.7, representing functions as graphs. This is the final lesson for the unit. Let's dive in. They say graph the function with x values of 2, 4, and 6. And they give us a few equations here. So this should be equal to y. Y. Alright. They say y equals 2x plus 5, right? So you have to graph functions for 2, 4, so 2, 4, and 6. Right? The first thing you want to do when they give us this kind of equation is make a table, all the x and y values. So just go ahead and do that, where this is x, this is y. X equals 2, 4, and 6. X equals 2, you do 2 times 2, that's 4 plus 5, 9. When x equals to 4, it would be 4 times 2, 8, plus 5, which is 13. 6 times 12, 6 times 2 is 12, plus 5, that would be 17. So if So let's say that's 4, 8, 4, 8, 12, 16, and finally 20. So 2, comma 9 should be about, if that's 8, so your 9 will be right about there. This would be 2, 4, and 9. When 4, it's 13. This is about, that's 12 right there. 13 will be right there. 9 is 17. That's 16. So 20, 17 would be right up there. So your graph would essentially look something like this. That would be a graph. So that means the point is that point would be right there. Right, so obviously there's a linear graph, and the y coordinate and the x coordinate. Now, sometimes they'll ask you, like, predict the y value when x is negative 5, right? So instead of based off of the graph, they'd give you like this sort of graph, and then they'd say predict the y value. So instead of just like tracing your way all the way back and assuming it, you can go ahead and just plug that in. So if x is equal So if they say like something like if x is equal to -5, find y. If that was your question, they would, instead of solving for the y value, you can just go ahead and plug in the value for x. Right, so -5 times 2, that's -10, plus 5, that would be -5. So your y value would be -5. Alright, let's go on to the next one. Okay, let's just clear up some space. This. Alright, let's Control C. Clear up some space, Control V. Alright, moved it there. Some space. They say x times 2y plus 5 equals to 9. So here you'd have to distribute the x first, so your equation would have be 2xy is equal, no, my bad, plus 5x is equal to 9. Right, so you'd move the 5x to that side so that you get 2x y equals to 9 minus 5x, and you divide both sides by 2x, you get y is equal to 9 over 2x minus 5x over 2x, where the x's would just cancel out and be left with the equation y is equal to 9 after the equation 9 2x minus 5 over 2. So that'll be your final equation. So you can remove out all of this. Control C V. Right, so this leads us to that equation. So once again, the table would come in handy. X and y, where x equals 2, 4, and 6. x equals to 2, 9 over 4 minus 5 over 2. That's 9 over 4 minus 10 over 4. So that'll be minus 1/4. When it's 4, 9 over 8 minus 5 over 2. So 9 over 8 minus 5 over 2 would equal, let's see here, 9 over 8 and 5 over 2. You multiply both sides by 4 and then you get 20 over 8. So this can be, so it'd be 9 over 8 minus 20 over 8, which would be negative 11 over 4. Right, so I'm not even going to bother with the 6 value because we already know it's decreasing. So when we plug in those values at 2, plug in those values at 2, 4, and 6, your equation would already start dropping down right there, right there. Not sure, right there. So your equation would look something like that. Exactly that, but most likely like this. So that would be pretty close to your equation. Now let's go on to number 3. Number 3 says, okay, so this would be pretty easy because they already expanded it for us. So you'd get y equals to x minus 5 over 4. You can go ahead and draw the graph if you want, but that would look, Control C. When you graph this, it would look something like this. X over 4 minus 5 halves, right? So it would look like this. Your linear graph again, go up with that. Hopefully you get a good feel as to how this is. Go ahead and do the triad problems. They're very close to what I did in the examples. And I'll see you for unit 2 next time.